So it's been a long time since I haven't streamed. So today I'm going to try to implement string physics with Rapier JS. I built a different project and I still haven't figured out the zoom and drag thing, but if I have time, I think today I'm also gonna do that. But I'm not really sure if I'm gonna have time or not because it seems like it's gonna be harder than I thought it would be. I thought I would be done with this yesterday, but it's more difficult than I thought because I tried to implement this joint data here, this Revolut joint, and I don't understand really well how it works because I was thinking that the way that it's gonna work is you pass the position of each where you want the restriction of movement to be at each element, and then it's gonna create like a link between the two in the physics engine. But I don't think that's how it works. I think the way that it works is more like it connects the two different objects into these points you pass here as objects, and that becomes like the restriction of movement between them. So what's happening is that they are going on loops here. That's the problem. Like it either goes on loops or it's like explodes everywhere. I'm not really sure how to say it. So I'm gonna have to figure out how to do it. It looks like they don't have anything about this. So this is what's happening right now. But yeah, and it also like it seems like it's gonna be very fun to do this once I finally understand how everything works. But it's gonna take a lot of time to understand how the physics engine works, because it is very complicated. It is harder than I thought it would be, to be honest. Because I wasn't thinking about the collisions and the mathematics behind it. I'm gonna put some music for myself. Like, obviously, I was thinking about the mathematics, but I was thinking, like, I forgot that on the collision, like, you're gonna have to calculate the velocities and the deltas and stuff like that. It's very annoying. But it seems like this is probably the right path to go because, like, there's a lot of ideas that I have to, like, do some really crazy visualizations, but and this is the thing that the reason why I think that it is a good idea, because the more you work to make the visualization, you have to force yourself to think about the mathematics and the physics behind the visualizations. So that's gonna help me like understand, I think, better, because essentially what I want to do, I think I'm gonna try to do this, but I'm not sure how hard it is on the main page. I thought it would be an interesting idea to create a line between like the left and the right, and then on the left make strict patterns, and on the right make more chaotic patterns, and then make an animation that transforms the line into a vortex that connects both of the sides of the symmetry. And I thought that this would be a good idea because it's kind of like I want to be able to put the visualizations of what I'm thinking, like be able to visualize what I'm thinking, and I think that's gonna. But it seems like it's a very hard thing to do, so I'm not really sure if it's worth it or not, or if it deviates too much from the. I think putting all this stuff, trying to allow it to, or make it possible to visualize for other people to visualize what I'm thinking is gonna make it make me force myself to think more about the nuances of how everything connects. So, and that's gonna help me increase the chances of AI alignment by building the blockchain, because I think obviously it's connected. So being able to visualize space-time in a very high degree of accuracy goes hand in hand with building a network that reaches equilibrium over space-time. And on top of that, like, it merges the two different goals. So I'm kind of like starting to get more and more excited to build this stuff, and I think it's gonna get easier and easier the more I build it, because it starts getting interesting once you are able to visualize this stuff you do. But I'm still at the point that it's very hard because it's kind of annoying. Like I suck at it, obviously. I just started, so like I'm not very, it's gonna take a long time for me to like see the stuff that I'm doing, to figure out how to do the physics. And this is the part that's I'm gonna try to do now, and it's kind of annoying to do it because it's not very interesting physics. It's just the physics of the spring, which is k times x, I think, divided by 2 or something like that, or k times x to the power of 2 divided by 2. It's going to determine the stiffness of the, not sure if stiffness is the right word, but the resistance of that the spring has and the forces between them. I studied this the mechanical engineering in college, but it's not very interesting. It's just like more, it's gonna be difficult to implement, but it's not very interesting. So hopefully I can implement this somewhat fast, and then move on to things that might be more interesting. And the challenging part is gonna be to study the source code of the physics engine to understand how they do the collisions and everything else. And I'm really glad that they did it, the documentation like this, because it's kind of hard to search for the source code. So here they have all the methods and classes. So I think I'm gonna look at this, go over the stuff that I have here. I got this code from an example that I saw before I asked this question. I also searched on the Discord for previous posts that they had about the spring, and it looks like nobody has implemented a spring yet. There's only one guy that made a pull request to implement springs, but it was in Rust and it was outdated because they changed the library several different times. So nobody has implemented a spring physics yet. And I found something similar to what I'm trying to do from here, and I made a lot of changes. So because of that, I created a different project only using Vite, because I thought, like, in the project they had, they didn't have to do the whole dynamic import thing to use Rapier. So I thought that it might be because they were using Vite, which is a different compiler than Next.js uses. Next.js uses Webpack, and Vite is also faster. So I thought, like, maybe I should try to create another project and like do everything the same, just use Vite instead of Next.js, which is gonna be harder because then you have to deal with more stuff. But then I did all of that, and then I realized that that wasn't the case. I'm still not really sure why. Like, obviously here is possible because of the way that they structured the code. So they did asynchronous import. But there's something weird because when I change the file to be JavaScript instead of TypeScript, it messes up the import again, and it gives me a warning. So I think it has obviously something to do with TypeScript, but I'm not really sure. But I think that after I figure everything out, I'm gonna move all of this code here to the Next.js project again. But I'm still not really sure if I should go with Next.js or Vite. But yeah, probably go with Next.js. So I think I'm gonna look at this one, create impulse joint. I have to look at all the methods. The thing that I'm trying to clarify now is whether or not I should use these joints, or if I should try to change the forces on the bodies to create because the problem here, from the way that I'm thinking about now, is that I don't think that I'm doing this stuff wrong, because here, like, these points are relative to the position of the body that you pass here. So, like, this should be at the center of the ball, let's say, for each one, I think. But the problem is that it creates the joint, like, it tries to connect the two different balls. And because of that, because you have the collision, it creates this spin effect. And the way that I was previously thinking about the joint is that it's going to put the joint on the center of each one, but it's not going to try to merge the two. So what I'm trying to think about is how can I make something that is going to keep the distance. Like, I'm going to be able to change the distance of them based on the physics. That's the challenge. Because ideally, I want to build. I'm obviously gonna right after I finish this and I finish the zoom and drag, I'm gonna work on something that allows you to customize the physics simulation. And to do that, I'm gonna have to create a component that is gonna have that is gonna change the stuff here based on the data, the variables. So ideally, I will have something that, as you change the gradient of the, I forgot the name of that thing that goes from left to right. The name of the, I think is range. So like by changing the gradient, the range of the inputs, you would change the how close or how far apart they reach equilibrium in relationship to each other. But the problem here is that with this simulation, I don't have, I'm initializing without gravity. So this is the stuff that I don't understand really well, because I don't understand if they view mass like as a part of the simulation in relationship to, like if mass is in relationship to the objects and to the world itself, or if it's just to, if you don't have any mass or any weight, if your simulation doesn't have gravity, regardless of how much mass you set for the objects, because obviously if you don't have gravity, there's no force pushing, but that's weight and there's not mass. Mass is intrinsic property of objects, and weight is the mass times the acceleration of gravity. So I don't know really well how they did this. So there's two different things. One of the things is it can be the joints that's, because of the way that they designed this, it can be the joints that are trying to be connected, and because of that it generates the spin. Or it can be because they don't have mass. So when you put the joint, it works like as an attraction force, and because they don't have mass, they don't reach equilibrium. So if you put the mass in the objects, it's gonna have an attraction force, and then it's gonna reach equilibrium before, like you can change the gradient, and it's gonna change how far apart they are, because where they reach equilibrium. So, but I think I tried to change the mass of the nodes here, but it doesn't seem to change anything. That's the problem. So now I'm not really sure if it is because the simulation doesn't have gravity, or if it is because of something else. I also have to think about, like, this is stuff that's kind of hard to think about, because I don't know what is the standard way. I also found these projects here as well. That's implement zoom and drag. I think I'm gonna try to study the source code of them to see, but they use the D3 JS, I think. So I'm gonna have, I'm gonna see if I can convert the code here to, like, see the source code of D3 the way that it is implemented here, to add the zoom and the drag, so I can emulate the functions on my own thing, because they have both zoom and drag, and they have event listers on the nodes themselves, which is what I'm trying to achieve. And what I was thinking about, the way to implement this would be to put an event listener on the canvas and then calculate whether or not the position of the click is inside of any element of the canvas. And if it is, then you do something else. And if it isn't, then you drag the canvas, change the view of the canvas. But I'm not really sure. Like, it seems that I'm missing something, because there must be an easier way, I think, maybe. Because by doing that, I'm gonna have to calculate the positions of all the objects, all the elements, every time someone clicks. And if it seems like it is inefficient, because then it's not gonna scale with the size of the graph. That's the problem. So if I have 2 million nodes, like, we're gonna have to calculate the position of the 2 million nodes every time you click the canvas. But maybe it is the right approach, because you're gonna have to do that anyway, because for changing the view of the objects, the position, you have to know the positions, obviously, on the drag. So maybe that's the way they implement, but I'm not really sure. And they're just changing the scale. States. Let me think about what is the best way to go about exploring this. Maybe I should get the equation for the spring, and then once I have the equation for the spring, I put it in a function. Let me think about it. Like, I can emulate a spring by creating two different forces, obviously. So, like, on the axis of translation between them, I think, which is like, but that's the other thing, because there's two different axes and they can move, obviously, is x and y. So depending on whether, like, I always want the force to be in relationship of the to the objects in the same way. So like creating a plane, but then if you rotate the plane, then it changes the angle of the forces. So let's say you have, the thing is, it's kind of hard to explain what I'm thinking about, so maybe I should do this, but I don't want to spend a bunch of time on this. Oh, I did this stuff here, I think. Not really sure if I showed this. To study the Pixie event system. And I changed some things as well on the way that I was doing with the components, trying to simplify as much as possible. So, and I started to think that I might not even need React Pixie, because I'm not really sure what's the benefits of using React Pixie is. Like, they're using a custom reconciler, but it's not clear whether or not the custom reconciler is going to increase performance that much. Because it seems like you can achieve everything just by using the class and then initializing the class instead of the use effect of a component, and that's a lot simpler. So I'm kind of dubious about whether or not it's worth it to use React Pixie or not, because I don't understand the effects of the custom reconciler very well yet. But I decided to leave it like this for now because it's just simpler. So it's just easier, and I have a lot of other stuff to think about. Maybe sometime I will change this. Actually, this line's probably better. So what I'm talking about is that, like, if I have two nodes here and they are connected like this with a horizontal line, then the problem is that obviously if they change the position, the line is going to change. So that's the thing. Because if I initialize on the x component the forces, then what happens in the simulation when the elements change? Are the vector of the forces gonna change in direction, or just the magnitude is gonna be constant, and then the only thing that is gonna change, the simulation engine is gonna do, is change the vector of the forces, or do I have to manually change the vector of the forces? I think that's the first question that I have. Because one way that I'm thinking about that I can implement this just by using forces is just because there's no way to, if they don't have mass, there's no way to make them reach equilibrium. So like what I can do is just create a force on each one of them like this, and then create another force connecting the two. And then obviously the gradient is going to be the difference between them, which is going to determine how stiff the spring was going to be in relationship to the objects. And I have to take into account, like, maybe not, because it doesn't matter. Yeah, it doesn't matter their mass, because they're not going to have acceleration, because the simulation doesn't have gravity. So the only thing that matters is the forces between them, which is the strength of the spring. And their size doesn't matter because they don't have. But then again, it depends if they have weight or not, or if the mass matters. Because there's also moments of inertia, I think, which matters even if you don't have gravity, I think. maybe not. I think it does matter because you have a force on the mass. So like the greater mass is gonna have greater moment of inertia, even though it doesn't have weight. I don't remember really well. So I guess that this is the reason why it's kind of hard to think about the best way to go about this. 'Cause obviously, you can start trying to do a bunch of stuff, but and because I don't I don't know the standard way to do this. That's the thing. It's kind of hard to find videos about it. And so this is the reason why I asked this thing here. I'm also like asking more questions, but I'm still like it's kind of hard to know like what is the line to ask a question. I usually try my best to study everything and then like to make sure you're not wasting people's time, but at the same time I think it's not as sometimes is better to ask questions because why else they would have the Discord. So like I'm not really sure if it is a good question or not. I asked one question before this that I kind of regret because it's something very easy that I didn't look in the documentation because I was just studying a bunch of other sheets and then I was kind of tired and then I just decided to ask the question because I was tired, but yeah. So I guess the best way is probably to write these questions that I have. I have to understand the engine, that's the problem. The thing that I'm concerned about is that because they're using WebAssembly, WASM, then it might be the case that I don't have access to the source code because the actual source code is in Rust, and then it gets compiled into binary, and and you use the binary from JavaScript. But I think you still need to have like but this is the problem because if you have an API on JavaScript that calls everything from WASM and WASM is on binary, then obviously I can't look at the source code in WASM. I have to look at the source code in Rust, and then I have to translate to like what I think would be like a good approximation of what's happening. But I think I have to understand how the engine works first. I have to understand how the engine works really well, how they think about these calculations, because obviously they are going to be simulating everything based on tensors, which are like a tensor is a vector that is multidimensional. So a vector happens on three scales of observation, which is x, y, and z. And then a tensor is encapsulating multiple different dimensions into the same thing. So for the way that I think about it, at least I might be wrong about this, but if you have a vector, you would have like a number. The first number is x, the second number is y, the third number is z. And then you do all the calculations based on that. And if you have a tensor, then each number might be something else. So like you can have the fourth number be time and the fifth number be gravity or something like that, or any measure you want to put. And the way that I think about the dimensions is just like that. But this is another thing that I don't really know very well because it's very hard. Like it's very hard abstract concepts, dimensions, like to understand what a dimension is. But I think it's just a way to measure something. So anything that you can reduce into a concept is a dimension, I think. And you have infinite amount of dimensions under this lens because it's just a measurement of something. The measurements are always relative to the observer. So by definition, all dimensions are interconnected because they can only exist in relationship to each other. But a tensor is like a bunch of numbers that are going to have some form of measurement, which is the projection of a perspective into space-time, I think. Then the interaction between tensors can create an informational field in relationship to the thing that is perceiving space-time. because that's all that matters, because that's how you reach synchronicity. Like even that's the problem with non-duality and the stuff like that, because you reach a ceiling through the scientific paradigm, because you are encapsulated, you're always limited to the boundaries that your perceptions can take you. Because even if something is true outside of your capability of your perceptions, it doesn't matter, because it doesn't reduce to the field, informational field that you exist in. So it's not relevant to the survival of your identity. So I think that the synchronicity between observers creates the space-time, which is an informational field. And then based on that, you have the tensors. And then based on that, you have the simulation. So I have to understand like what are the assumptions that they are making and how they are calculating the collisions and the movement between different elements, so I can understand how to go about doing this. So I think that the best way probably is to try to understand the source code and the solver that they are using first. Because, and the thing that I was saying about the collision, and the reason why I think it's going to be a lot harder than I thought it would be initially, is because like essentially like it's an infinite problem if you think about it. Like if you want to go really deep, because it goes into quantum mechanics, I think, because the boundary is just an illusion. So when you have like two different objects and they are colliding with themselves, like how do you determine like the surface of the collision and how the surface is going to impact the consequence of the movement between the two different objects? And this is stuff that I forgot and I was taking for granted. And because obviously you have to calculate that, because then you have to calculate the velocity, the mass, the energy of the two different objects, and what's going to happen after the movement. And because your simulation is not perfect, you're making a bunch of assumptions. So you're going to reduce the resolution of the physics based on the assumptions, which is a relative reference frame you have. And that's the laws of physics you have. So like it's just a projection of your assumptions. And if you want to go really deep, you can think about it like the surface being rough of everything, because it doesn't exist. The deeper you go, it doesn't have anything, because it gets through quantum mechanics, and the boundaries between objects is just an illusion. So the interaction between the objects and how they connect is just like connecting two different multifractals. And then calculating what's going to happen, like with exact precision between them, is going to be an infinitely complex problem, because you don't know how the multifractal is structured. But obviously you don't need to do all that, like just to do a simple simulation. But I think it is like something interesting to think about, and it is the stuff that I was thinking about at the beginning. That's the reason why I think it's going to be very interesting to try to create a simulation, because that's what I think, like that's how I think gravity is like you have the yin and yang symbol, which is a line that separates relativistic symmetry, and inside of the symmetries you have a vortex, and the vortex connects with itself through the dots of the yin and yang, and that's the symbol of a multifractal essence of the law of gravity, which is how black holes work, I think, as well. So you have like different points of space-time connected through this. Maybe not. Maybe I'm just. There are obviously a lot of stuff that I might be missing, but I think that's the essence of perception, let's say. And the boundary, which is the line that forms the vortex, is the multifractal, because that's the evolution of information. That is the stuff that I was thinking about the other day, is that like the essence of time, the evolution of time, is the figuring out where the line is, which is the evolution of politics and everything else. It's like you have a relativistic polarity. So if you think about arguments that people have with each other, they are always trying to reach an equilibrium point, and like you have people on one side and people on the other side, and this is what a debate is the interaction of the electromagnetic field. And the relativistic polarities create the evolution of the information, which is the interaction of all these relativistic symmetries that creates the flow of space-time. So I think like at the line of everything is always infinite, and that's the reason why you have these debates, because that's the evolution of time itself. Because you can only have these discussions if you have the reference frames that create the relativistic symmetry between them. So the evolution of time itself is the evolution of information, which is the discovery of this process of achieving Nash equilibrium relationship to different conscious agents. So figuring out where the line is like figuring out what time is, because it's the same thing. And I think that this goes from abstraction to the physical reality, which is like quantum entanglement between the two. Like is a multifractal essence of identity, which is the pattern that I was talking about before. Let me think about this stuff here. Yeah, so because I know that there are different forms, there are different bodies as well. Maybe I should read this again. There are kinematic bodies. There's also like the way that it works on like normal mechanics, I think, like range mechanics or something like that. From what I can remember, is you have two main different forms of energy on simple simulations, which is the kinetic and potential, and they create the relationship between the y and x axis. The potential energy is on the y axis, and the kinetic energy is on the x axis. And the movement of objects is going to be determined between the two. And then in most cases, I think you assume conservation of energy, but then you have obviously you're going to have loss in the real world, and it's going to be far more complicated because you're going to have friction, and you're going to have temperature, you're going to have sound and everything like that. So the more accurate you want to go, like it's like a gradient, it gets more and more complex until it gets infinitely complex, which is the limit of quantum mechanics, I think. But here, I think it looks like they have two different types of bodies. And one is this kinematic or something like that. Oh, they have fixed and dynamic. Fixed doesn't move, dynamic moves. And there's something about kinematic here as well. So I assume that they are doing kinematic and potential energies for the movement of objects, and they are not doing anything else, obviously. Because I think the other stuff is just for, like, it doesn't... Maybe it does, actually, to some games, but it might not be very essential, I think. And there's also like fluid dynamics and stuff like that that gets very complicated very fast. So I have to remember like the laws of physics, the acceleration, how acceleration is related to velocity, how velocity is related to time and mass, and how impulse also affects the objects, that kind of stuff, and how they are deciding how to simulate each thing. I was also thinking about a flat Earth the other day, and I don't even know if I can explain like with a high degree, not even with a high degree, like why the Earth is round and not flat. I was thinking about this, like obviously like there are several assumptions that I have about like it's kind of funny thing because I think that it's more likely that the Earth is flat, but not the way that people think about it, obviously, but from like more like from a different way, let's say. because usually that's what happens. Like you have, like the beginning is always similar to the end, but 360 degrees different. So I think these two positions are very similar. Like first the Earth is flat, then is round, then becomes flat again from another perspective. And I think this perspective is just the essence of space-time, because some people say, I'm not really sure that makes sense or not, that space-time itself is flat. So from that perspective, the Earth would be flat as well. And I was thinking about these things. Then I was thinking about like, why do I think that the Earth is round? And it has to do with the relationship between gravity and the movement of objects, because the more mass you have, you create acceleration, and then the acceleration creates torque, and then that torque makes the mass converge to the center, which creates a circle. So, and then I thought about like, what would be the limit for a cube in space-time, if that's the case? Because then, and this is the stuff that it gets complicated, I think, because it depends on the density as well, not only on the shape. But then you can argue that they go hand in hand because it is the same thing. So it's very difficult to think about this. And I think it's not so obvious. Like, I know people like might say I'm crazy because of this, but yeah. You also have obviously like radio waves, satellites, things like that, GPS, that kind of stuff. But then how do you explain? I don't know, like for sure, the explanation between these things, like why. And I think it's also dumb to assume that you know for sure that the Earth is round, because realistically you don't know anything. So I think most people deviate from either side based on the relative consensus of the norm in the whatever time they are in, because that gives you more comfort and allows you to spend less energy. So the more you judge other people, it reduces the energy you have to spend thinking about it and reflecting, and sitting on uncertainty is very uncomfortable and very dangerous. So that's why people go either way. But I think I would be willing to bet that most people that say that the Earth is round and make fun of people that think that the Earth is flat, they don't know why they think their Earth is round, which I think is even worse than believing that the Earth is flat. Because that means you don't understand why you think the way you do. And you just make fun of people that think differently than you. Without even knowing why you think the way you do. Like someone downloaded something in your mind and you assume that it's true. Because that's the norm. So it's kind of ironic. And obviously it's dangerous because like the way that history shows, but it's gonna be like that regardless. I think that like is the shape of the collective consciousness, because that's how mass creates norms over time. Is all related, I think. So 80% of the people are gonna believe things that they don't know why they are believing, just because that's a current norm, and then that's gonna create the judgment, which is the morality. There's always gonna be these arguments. So this is something interesting to play around. I wanna write here. I think I'm just gonna play around with these things as well, because it is interesting. So I have to see like, yeah, but that, yeah, like what are all the rigid bodies that I'm creating, and then I think it's just I'm just creating the nodes here. The edges are gonna be the forces. Is not gonna be a body, I think. So the only thing that I'm doing is creating the ball. So here, like changing the, that's a question as well. So the way that I'm doing is looping over all the nodes here, and then I call this function, pass this stuff, and then I push to the nodes. Maybe I shouldn't have said this stuff about the flat Earth, because it is kind of dangerous. I don't have a lot of subscribers now, and I've been thinking about this as well. But I think that it is kind of like it goes back to the whole freedom of speech thing, and it gets complicated because, like, I don't think censoring is necessarily good, but it's not bad either. It's like more nuanced than that, because the speech is correlated to the power and the influence over the network, and then that creates like it can increase the tension, which can increase the chaos, and like maybe in a way that it's not necessary, let's say. So it can be dangerous. That's the reason why people, like, it is dangerous to search for the truth, I think. And a lot of people, like, because it's considered to be something cool, a lot of people judge people that don't, but it is actually a very risky thing to do, because you can become crazy. And that's the reason why people have all these mechanisms of self-defense, because they're trying to preserve their ego. So if you hear ideas that go against the stuff that you believe and you try to maintain, and you easily believe on them, if you're too open-minded, then you can lose yourself on that, and you can destroy yourself. And so let's say you start believing that you can jump off a bridge and you're going to be okay regardless of how high the bridge is, then you jump off the bridge and you die, obviously. So your body has mechanisms to protect yourself from doing that, and that's why people are closed-minded, because it helps them survive. And it's obviously going to be a gradient based on the genetic distribution of the personality traits of people that are open-minded and people that are closed-minded. And I think that ratio is going to follow a pretty distribution, which is 80% closed-minded, 20% more open-minded. And that's going to be the flow of information into the collective consciousness. The problem is that this is correlated to the power of the network. And so the more followers you have, the more influence you have over the network, the more your message is going to change the structure of the network itself. So if you're not careful to regulate your speech in relationship to the power that it has, it can have a more damaging effect. And but at the same time, you don't want to censor yourself, like, because you don't want to stop creative expression, which is the concern on the other side of the freedom of speech, which is very reasonable. And I think the problem with the whole freedom of speech thing is because it becomes a self-fulfilling prophecy, and it becomes a vicious cycle because of the way that the dynamics of people work. We are always incentivized to have more power, and then people get corrupt over time. So it's not the problem. The problem is not censoring. The problem is who is censoring, because they are always going to want to censor more, because that's their unconscious mind trying to survive. And the way that they do that is by trying to align everything with their worldview, and they do that by censoring other people. So I think that, like, the answer is not on either side, and that's the reason why I think that Elon is trying to implement things the way that he is, because he understands that the speech can be a problem based on the magnitude of the speech. So trying to preserve freedom of speech, but at the same time regulating the influence that the speech has. But then you get into the same problem, because you didn't solve the problem. It's just one step more, because now you have the problem of who is deciding who is going to shadow ban people. And is in the essence is still the same thing. So I think I'll be right back. So the reason I'm saying these things, like, is because I'm not really sure, like, from right now, I think that there isn't a problem with the stuff that I say, because I don't have a lot of followers. But at what point should you be more concerned about the stuff you say? Because it's like Kanye West saying that he loves Hitler. Understand the point that the place that he's coming from. Like, and I think a lot of people do. He's not saying that he loves what Hitler did. he's saying that he loves Hitler because he thinks that Hitler is a byproduct of the environment, which is true, and a byproduct of genetics, and everyone has a dark side on them. So, like, you should love people, but you should also have boundaries. Just because you love Hitler doesn't mean you follow what he did. And so, like, just because you love a criminal or a rapist or something like that doesn't mean you agree with these things. So, like, there's always this separation. And I think that's the place he was coming from. But then the way that he goes about doing that can cause more damage than good, because most people are not going to understand the place they're coming from. And that's going to create an effect on the network. And that's a problem with speech. And then people are going to play around with that for their advantage. So, like, some people use comedy so that they can exploit the nuance. And people do, like, all sorts of things. And it is very hard for someone that's, like, in my position now, that's creating content, to know, like, at what point do I draw the line and I start being more conscious about this stuff that I'm talking about. It's kind of hard to know. I'll be right back. Well, actually, it's better if I change the forces here, because obviously, or change on the edges. I have to access the body from the edges, and then I change the forces. That makes a lot more sense, because obviously I need to know the position of each body. Oh, but maybe. Well, I have to know which body to add the force to. That's the thing. But this also doesn't seem like it allows me to. But maybe I should just try. There's gonna be the thing that I talked about where when the object moves, if I'm not moving the force, then like if I'm not changing the x and y with the movement of the object, then it's not gonna produce the effect that I want, because the force always has to be, the vector of the force always has to be constant in relationship to the other node. It has to be the same, and that's gonna obviously gonna change depending on the angle of the movement of the object. So it's probably gonna be with sine or cosine true. And the question is, how do you maintain the force parallel in the same plane in relationship to both objects from the way that it started, I think. I think I'm also gonna put like this is much better. And then I replace everything. This is also something weird that is happening, but I think it's because of the hot module reloading. That's every time that I save, the ball gets faster. So it's something to do with the engine and what happens when you do the module reloading thing. It's not the size of the canvas because the walls still work, I think. One thing that I can do is just do. It doesn't seem very efficient, but oh, maybe it is. It doesn't seem very efficient actually. I was gonna say I can recalculate all this stuff. I can put it on the draw edge function instead of the edge factory function, because here I'm creating the physics, and then on the draw I'm drawing the, like, trying to draw what the physics does, and then the drawing goes inside of the loop, the ticker. So the physics is only created once, and then the drawing is created each time on the loop. And obviously, I believe, otherwise it wouldn't make sense, that after you create the physics for the first time, the engine is going to take care of changing everything else on the simulation. So the first time it creates a snapshot, let's say, of the position in the physics of everything of the world, and then each time after the step is gonna recalculate everything. So you only step here, and that's more efficient, because I think then the WebAssembly stuff handles the calculation of the simulation, which is probably faster. So I was thinking about adding the forces on the draw edge function. So that way, each step I can recalculate all the forces, but it doesn't seem like it seems that is an anti-pattern, let's say, because I should only create the thing once, and then it should work. The engine should do the rest, I think. That's probably the better way to do it. But if I create once here, then how do I make sure that the forces are always the same to maintain the relationship between two different bodies or more? Let's look for what it is. What is a kinematic body, rigid body? So I think the torque is always in relationship to the body itself. There's the thing that I was talking about, gravity and circles, or balls, because they have acceleration, and then that's gonna create a force. Centrifugal, I think, is the name. Force to the center. So when you rotate, because that keeps the parts of the object in orbit in relationship to the center, then the center has higher density than everything else. And that's the torque. So it's like a vortex or gravity. I don't really understand very well what gravity is as well. Because I think from general relativity or special relativity is the deformation of space-time, or the curvature of space-time. But I think that nowadays people are not sure about that, and I'm not really sure as well, because I don't know the most advanced theoretical physics that people are doing, what they are thinking about. Obviously, it has to do with the theory of conscious agents, probably, or some other planes that give rise to space-time somehow, or. But I don't really understand what that stuff means, or Like, what is extra dimension or something from other dimensions? What does that mean exactly? Also, I think this is also something that I'm kind of confused about, the relationship between the collider and the rigid bodies. Because if the collider computes the physics, then why have the rigid body? I think the rigid body is just to describe the properties. No, maybe the collider describes the property of the rigid body, but then, like, why have the rigid body in the first place? Why it's not the same thing? This seems like it's gonna be useful for springs, because you want to create the a feeling or sensation, don't know how to say that, of the true objects getting slower or faster depending on how much you stretch the spring. Oh, that makes sense. So the bodies determine the physics of the object, and the colliders just determine the heuristics for how the collision is gonna happen. Obviously, makes a lot of sense. Hmm. I'm thinking about the whole cancellation thing, cancellation on the freedom of speech. I think it would be interesting if someone did like a machine learning model that captures the problem would be how you define like what does being canceled even mean. So, but like a correlation between the amount of followers and influence someone has and when like the problems start happening like at a societal level. I would imagine that is very high, like millions of followers, but maybe it happens a lot before, like way before that. And I guess it really depends on the type of content that the person does as well, because obviously depends on what kind of people are watching the content as well. This is interesting as well, so they probably do it to optimize. So it's definitely gonna be in the body that I have to implement this, I think. It's either the rigid bodies or the joints, the best way. Or maybe character controller, or yeah, character controller has something to do with it as well. I think it's more likely. I think the best way would probably be through the joints, but then yeah, I have to understand how joints work better. But I think Rapier maybe maybe with Rapier is not very good to do it with the joints. So I think joints is the first thing that I should try to make it work with. If it isn't possible, then try to do it with the rigid bodies by changing the forces. And that's what I'm thinking about now. Yeah, this is the stuff. This is the reason why I thought that it's kind of confusing, the colliders and the rigid bodies, because of this set density. Maybe set friction as well, but friction I think makes a lot more sense to be on the collider, because obviously it's the roughness of the surface that's gonna determine the friction, or the stiffness of the spring, maybe. Not sure if that's. I think it is not related to, unless the edge is an object itself. But then it wouldn't be related to the stiffness of the spring, because it's just about the edge on the surface of the edge. So I think that friction makes more sense to be on the collider, but why density is on the collider? I guess the collider itself has a mass on top of the object that is simulating. I think fractals are infinite dimension. I was thinking about now. Like, how many objects can you create on space-time? And it's obviously gonna depend on the connection of the points that make up the object. And I think that the gradient of that's gonna be a fractal. I think that's the reason why I think that the space-time is connected to the complex plane. Complex plane is the representation of abstraction or imagination, and the flow between the two is the flow of space-time. Because if you think about it, this is the reason. Like, I tweeted something like this the other day as well, because I was thinking about this. Like, if the bottom layer of reality is infinity, then why isn't the field of view of myself, like an observer, is infinite as well? And like, why isn't the field of experience infinite? But then it made me realize that I think that it is infinite, but the infinity is on time, not space, and they are connected. So the limitation is on space, but the flow of time is infinite. So the passage of them is the essence of space-time. And the boundary is at the multifractal that creates the illusion of separation between different objects. So the flow of information it comes from the complex plane, and then it becomes space-time. And the differences between the two is the funnel of information, which is a funnel of density that creates the separation between different things on space-time. And that's why time is always moving, because it is a relativistic thing in relationship to an observer that creates the different boundaries, and that's geometry. So fractals are infinite geometrical structures, I think, or multifractals. And the evolution of them becomes geometry, because the simple geometry is more well defined, but even that geometry is made out of fractals itself, because at the boundary of that geometry there is a fractal pattern. And the simple geometry is just a lower resolution of uh, the plane of the field of view of an observer. So it's like a funnel, and the more simple the funnel, like simple quote unquote, the funnel becomes in relation to an observer, the more defined the geometry becomes. But at the bottom is always a multifractal. So the more complex it becomes, the roughness of the surface contains the complexity of the evolution of space-time, I think. It is a trippy thing to think about as well. And this is an interesting thing to think about as well. And I think it's related to the stuff that I'm talking about. That's the GPU buffers, and they work based on triangles. And the question is why? Like, why is that the case? So everything is drawn with triangles. And I think the reason might be because of this, the essence of the evolution of information, which is a hierarchy, but maybe it doesn't make sense. So like the visual field is a hierarchy. So triangles are like this simple representation of that. And it is a multifractal, obviously. So but the relationship between different hierarchies creates the illusion of maybe not the illusion, but creates the perspective of something. Yeah, that's what I was thinking. I think soon I'm gonna stop streaming probably to go eat something. I think I'm gonna stream less often for some time. Just wanna see if it's better. I think I'm streaming too much probably. So, but maybe I'll go back and forth and change depending on what I'm doing. And for what I'm doing directly doesn't matter. I think that much those things because I can do the simplest, most basic thing possible to create a graph. It doesn't matter that much the collision between the nodes. That obviously, I think what matters most is the size of the nodes, the mass that they're gonna have, and the size of the strings, and allowing people to change those things based on the visualization. I think that's very important. But everything else is not that doesn't matter that much. But I think for future things that I might do, it's definitely interesting. And I think it might be interesting even for the stuff that I'm doing now. Because I don't know, like, I think even if the stuff that I'm trying to do is not very good to like visualize the codes, like being able to implement these things like is gonna allow me to and understand the physics very well. Like there's an infinite amount of things I think you can do because you're just translating like information into visualization, which is very interesting. There's stuff with music I was thinking about as well. Should be very interesting, but very hard to do, I think. But it seems very interesting to me. And to be able to capture like some visual properties of music, that would be very interesting. Let me go to the giants. I'm just gonna read this stuff. It's kind of boring, but I think it's not worth it to, like, I can try a bunch of stuff and just see how it changes the visualization. That would be more interesting, I think, for streaming, but like I don't really care that much, I think, because it's more important to understand how it works first really well. And I read the documentation several times, but I think I read it too fast. And I have to think more about how does it work. Um, to think about what is the best way to go about it, to implement. The question I think I have in my mind now is like the goal is to reduce the freedom, degrees of freedom that the body has in relation to another body, I think. But then why does doing that creates that these movements? It doesn't make a lot of sense to me. Because they're supposed to be like they are being rendered randomly. So like just reducing the degrees of freedom shouldn't create a force that attracts them, I think. And the question is why does it do that? Or maybe I'm not like I don't understand really well how it works. It also kind of is not necessarily what I want to do, I think, as well. Because, yeah, let me think about this. I don't understand what this means very well, I think. What does removing the relative translations between the two bodies, how does that work? That means that the two bodies are, is relative, so maybe it does mean that they are connected, let's say, and you can't move one in relation to the other. They only move if there's an external force on them. But I'm not really sure if that's how it works. I guess I can change here the values to show. I tested a bunch of different ones, and then obviously if we put the from body there and to body, it's gonna explode everything. And I think the reason why is because these values here are in relationship to the object itself. So this is like the position of the joint in relationship to one body, and this is the position of the, but is the position is in relationship to the object itself. So this would be outside of the object. And I think that's the reason why it makes it explode or like get out of control. Yeah. Interesting. This is slightly different than what happened the previous time. Hmm. Oh, maybe it is working. I'm just dumb. I'm pretty sure if I put this one here, it's gonna blow up, I think. Oh, it's not from body, it's from max. I don't understand really well like what these positions do. And that's what I have to clarify. And they just explode. So I guess I just tried with large numbers on this one and small numbers on this one previously. But I remember it was very chaotic as well, the values that I tried. But this one seems to be stabilizing at some points. So maybe this is the correct one. I didn't draw the edges yet because I think it wasn't drawing with the... Maybe I should do that now. Should uncomment the edge graphics or the draw edges. Because that would make it easier to visualize, obviously. Maybe it doesn't make easier, it just makes it more confusing. But here it's not showing, that's the problem. So there's something that I'm doing wrong to draw them. And it's probably this stuff here. Maybe it's because, no, I am beginning. So I begin the fill here, so line style. It can be because of the way that I'm doing this thing here. But the thing is, this is another question that I had, but I'm just deciding to go with the way that the person that built this thing did, which is how many graphics you should use. Should you create a new graphic for each element on the thing, or should you create a new graphic for each different kind of thing, like different kind of object? Right now I'm doing like that. So I have one graphic for the... But the thing, yeah, I have one graphic for the nodes and one graphic for the edges. And then the thing is that for the labels, I need to put one new type of class for each different node. So the labels are different because Pixie makes you do that like this. You have to initialize it with the text in the beginning, so I have to create a different one for each node. So this is another thing that I wasn't really sure, because, yeah, like, what's the best way? What's the way that is most optimal? Maybe this is the best way, because you create just once and then you do all the drawings of the same graphics, but maybe it's not ideal. I think I'm gonna know when it's time to create the events. Maybe I should end fill here inside. Maybe that's the... Or I should begin and end inside of the loop. That's why it's not working. It doesn't look like it changed anything. It can't be the colors, because these colors are the same from the nodes, so it should be like the color of these nodes here, the line. So why isn't it drawing? Maybe I should just console log here. Just see if it's going through this stuff. Fuck. What's... It's undefined. So is the stuff that I'm passing there? I did in a similar way that the way that I was doing before, where I'm creating a... I thought this is another thing that I was thinking about. So the way that I'm doing now is I have the list of objects which are the nodes. Then as I create the nodes, I create a map from the body, from the ID of the node to the body, and I make each ID unique. So each node has an ID, so I can keep track of all of them, but then the names can be equal, so that if you have two nodes with the same name, I can change the logic later to compare them and change the graph based on whether or not you want nodes that have the same name to show up, or you just create a new edge based on the name. So for creating the edges, you need to have a mapping from the ID to the body, because Otherwise, it doesn't work because it works, but then you have to filter the edge and then look for the ID because the edge is the list of objects itself as well. Just think of whether or not it's better to make the nodes be an object, a nested object, instead of being a list of objects. But then I decided that it doesn't matter that much. But maybe it's better if they are a list of objects because then it's easier. You don't have to create the node map. So it is slightly better, I think. But there might be downsides later on, and that's the problem. Because the challenge with this is that, and this is the stuff that I'm spending the most time thinking about, because doing all this stuff is not that hard, I think. The hardest part is like thinking about the system as a whole and how everything's going to connect. Because I don't know how I'm going to scale this very well, because it's going to depend on what kind of information I can get from the scripts or from the code and what kind of thing that I want to do. That's going to change the structure of the graph, which is going to change the structure of all of this stuff here from the physics. So, and obviously depending on the layout of the website as well, how the pages are going to be connected. I'm thinking about using more canvas on one page. That would be really interesting as well, but that like adds a bunch of complications as well. Then there's the state of the React and how that's going to be related. Like how all the canvas are going to be related to each other based on the life cycles of the components and the event listeners from each one. So it gets very complex. And it's kind of hard to decide what is the best way to go about it, doing this thing. So it's going to scale well, and I'm not going to have to refactor a bunch of things later on because I discovered something that changes everything. Just let me think about it. Let's see if I'm getting the edges first. Then I see. Okay, so this data that I'm getting now is just mock data that I created. So I can change work on the visualizations. It looks like I'm getting and I am getting the. Oh, maybe it's because I'm getting the different property. But I'm pretty sure it is the node map is an object. The reason why I did an object is because I think I need the radius. The radius exists on the collider. So before I was just mapping the ID to the body, and now I'm mapping the ID to an object that has the body in the collider. Yeah, that's the thing. Oh, maybe they don't have translation. The thing is that the code that I got from this is the reason why I said that the question I asked was kind of dumb. The first one, because I didn't realize I got this from the Discord, and then I was making a bunch of modifications to work for my thing. And then everything was working, but except one part. And then I asked the question, why? And then I didn't realize that the reason why is because they made it with an older version. And I thought the version that was most recent. So I asked some dumb question about that. And then I realized later, like, oh, fuck. Like, it's not working because it's not that their documentation is wrong, it's that they have the wrong version. So when I did that, when I downloaded to the most recent version, that stuff started working, but then other things broke because they changed the way that the classes are structured. So then I figured out what was wrong eventually. So, yeah, but it might be like, I think you should have translation though, because I think I am using this stuff somewhere else here. Or maybe that's the reason why this one is not working. Ah, didn't think about that. I thought, yeah, no, but I'm using here. That's the thing. So it should be working. Because this one is working. think I'm gonna cut the event listers or remove the event listers because it's kind of annoying as well. Yeah, let's call translation. Fuck. This is another problem that I'm not really sure what's happening because I pretty sure I'm sending the resize prop to the stage component, and that should make the canvas resize automatically, but maybe it's because I need to add the resize to the div, but it looks like the div like is resizing because it's here. So I don't know why this stuff doesn't resize, but I think sometimes it does. That's the thing. Like if I go here, oh no, it doesn't resize. So, but I think this is something that I'm just gonna figure out later on. Yeah, it should be working here. Maybe it's because of the way that I'm destructuring here. Oh, let me see. I think this is saying that it's undefined. Yeah, undefined. Interesting. That's probably the way that I'm destructuring this. I make this. Think I'll be right back. Let me see this first. Yeah, now it works. So maybe it's just the destructuring there. It's not working for some reason. I'll be right back. The reason why it's weird here to this not this structure here and is because here it seems to be working. So like one of the reasons I think it might be because it is a class, but and then that's the reason why it's not working. But then why would it work here? That's the question. And the only difference is that this is kind of tricky to think about as well because of the references between objects. So the difference between this one and the other one, I think, is just the way that I'm accessing. The other one I access from the node map. And this one I access directly from the object, which are the nodes, which is the nodes, and inside of these nodes here. So it's this object here. On that one I'm accessing from here. And then this one I'm accessing from here. But it should be the same thing. But I think that's the referencing, because the difference is that this one is referencing to this one, I think. That's the difference. So when I try to destructure, it doesn't work, because it's not the direct thing. Maybe. I think that's the case, and I don't think it's worth it to check with the conditions. I think I'm just gonna change this code so that it works. So this is the reason probably why this one is not working though. Maybe just I was confusing the things. I also thought about making, because the way that I was thinking about that the joint is the position inside of the body, I thought about that maybe I need to do the distance between them and put the joints in the middle. So that way that they're both restricted relative to the distance divided by 2, I think. But that didn't work as well. So I think it might be because it's not working. The destructuring is not working. So maybe that solves the thing. It creates the graph. So I'm gonna do that and then I'm gonna stop, I think. Still not working. Or maybe it's something else. Or I made a mistake there. Maybe I should just do one for the translation and then I access here. Maybe that's the better way. Oh, it looks like it is the position. So maybe it's the way that I'm drawing there. I think I saw this function as well. Like it's pretty intuitive what it does. So I think it moves the cursor to the position here. And then the line through moves the cursor to the other position and then draws the line. So maybe it's something else. Or maybe I don't need the collider. I thought I would need for some reason on these ones, but maybe I don't. So maybe it's better to just remove there, and I think that's what I'm gonna do. Because now I think it makes more sense. I think the thing that got me confused was just the density that is done on the collider, but now I understand that's just separate, and the density of the collider is the additional mass of the thing. And the collider is like the object, another object that represents the what's gonna happen when the object collides with something else. And the rigid body is just the properties of the body itself. So maybe I just need the bodies to create the edges, I think. That makes more sense. So I'm probably gonna remove the thing there. Here I'm just gonna make it equal to the body again. But first I need to understand what's going on here. Because if this is a position, then... Oh, actually, no. I was gonna say that maybe I have to put the 2y here or something, but it doesn't make sense. It should be the coordinates of the body here. So what is going on? Let's do it this way. Yeah, that's what I was concerned. I just wanted the algorithm, so I was gonna specify there, but... Oh, maybe... Yeah, that's the problem. So I have to begin this stuff after. But does that make sense? Yeah, I think it does, actually. Or maybe it doesn't matter. Yeah, whatever. Well, now it looks like some of them have. I just... No. It should be the color should be the same. Maybe we should just do white. Yeah, let me see. I remember that this stuff here is on a file. I guess I can just... Yeah. Just go here as well. Or maybe it's the color, that's why I'm not seeing. Let's see this strong. Yeah, is the color, that's why I'm not seeing. Maybe. Yeah. I think it's not because of the move through thing here. I wanna try this one first. But maybe it is though, because I don't really understand how the. I'm gonna read on the documentation how it works. Oh, so now it has here. Interesting. Also, it is working. Oh, but I think the edge doesn't do anything. Maybe it does though. So why does it work only for the first one though? I think it's because of the begin fill and the end fill here. And obviously this stuff should be here as well. Anyway, so so maybe this is gonna work. Oh, now I guess I can, yeah. I'm gonna change here as well. After I change here, then I'm gonna stop streaming, I think, and I'm gonna figure this out, how string. But now I think that the issue was just because this thing here. I thought the issue was because of the positions here, something I didn't understand about the joints. But I think this one's gonna work probably if I destructure here, because I assume this was correct because of the way that the other one works, I think. Because the way that I create these functions was just by copying the node ones and then making only the modifications that I thought would be necessary. Uh, yeah, no, it still fucks up. Interesting. And if I put 0, it's gonna be the same thing. Yeah, so I don't understand really well how this works. Let me make sure that I'm getting stuff here. And obviously, it's a problem that only the first one seems to have the drawing. And I think it's just because of the begin feel. Shouldn't be that hard to figure out, I think. Let's see here. Yeah, here it's outside. Maybe that's, if I just change there, it's gonna work. And I think the end fill is outside as well. It's the way that it was before. Yeah, now it works. Nice. So I'm thinking about how can I make it so that the lines are on either the lines are on the have negative z index or the nodes have positive z index so that it doesn't show the connection there. I think the reason why it might explode when you put the positions of each, maybe I should put on reverse on each one. That works. It's because you're trying to restrict the movement where the object is, maybe. Yeah, restrict the movement of one object in relation to the other one based on what the object is always going to be, which is its position. So it makes everything explode. I think that's probably the reason why. So maybe if I switch the order that I put, because here I'm putting the front body first and then the true body. So maybe if I do the other way around where I put the true X here. I think I'll figure out the Z thing later. Maybe it works now. Huh, nice. So I think what I was thinking is correct. You have to do the reverse order because you're restricting the position of one object, the movement of one object in relationship to the other. So the order that I did, that was restricting the movement of the object in relationship to itself. Or, like, you get what I mean. So, like, because the position is always in the place that it shouldn't be, then they explode. I think that's what's happening. So now it works, I think. Nice. So the only thing I have to figure out, there are two things. One is that the problem is that it's going to be more complicated than this because I don't want it to be like, it has to have more the spring feel to it, so it has to change over time. That's the problem. So the way that it is now, it just creates the restriction at the moment that initializes everything, but it doesn't change it at each step. and it doesn't have like the feel of the. It's always going to be fixed. That's the problem. So it should have some degree of elasticity, let's say. So the question is how to create that, because here I don't have, besides the initialization, there's no way to change this dynamically, the values here. So maybe this is a dumb question as well. Should we erase this and then ask the other one? It's really hard to know how to draw the line when a question is stupid. I definitely think that there are stupid questions. Because like most people, the tendency is for you to rationalize. So because most people don't wanna, not most people, everyone don't want to spend energy and wants to minimize risk. So like there are a lot of people that ask questions that are very simple, and it's kind of disrespectful because you're wasting people's time. And it's something that you can easily search for yourself. So, and that increases the noise a lot of the Discord. Is not very good. But then on the other hand, I think that if you never ask questions, then you're just wasting, like, why have the Discord then? Or why have any form of that? So at some point, I think it makes sense to ask questions, because you also don't want to be stubborn and not ask just because you want to figure out. So you need the balance. So, but it's very hard to draw the line of when is the right moment to ask a question, I think. I'm not really sure if that question is it makes sense or not. I think it's gonna be hard for someone to answer these things. But I'm probably gonna make a comment here about this and then ask another question. See if anyone knows. And the challenge is how to implement the spring effect, the elasticity on the thing, given that I can only initialize here. So I would have to do something on the draw edge function, I think, related to the edge factory thing. But that doesn't seem very efficient because of the stuff that I talked about earlier, where it's probably much better to just do everything that you want to do in relationship to the physics in the first stage, and then just let the only function that changes the physics simulation is the step. And that's probably the best way to go about it, because that way the engine handles everything. And if I do it like here, it seems like it's not very good. So I think I'm gonna stop here. I'll think about these things off stream. Yeah, let me think. Yeah, I'm gonna stop here. Probably gonna come back in a couple of days, maybe. So, yeah, who knows? So, yeah.